from one source of toxification of our environment to potentially another one. How many of you know what hydraulic fracturing is? Do we all know it by another name?
Fracking.
That's right. How many in here know that fracking is a big issue in New York State, especially upstate? That's right. A lot of people on Long Island have been asking about it because even though we have aquifers, they're still worried. They should be worried. And there's a lot of, let's say, disinfo, actually just a lot of info. What is the truth? It's time, the truth can be subjective, but information is information and you should have it. And it's our pleasure to have, coming down here, someone who's actually gone to the state legislature and talked about this issue under oath. His name is Jake Hayes, and he's here to tell you more about this issue.
All right. Well, thanks again, Ed and Gigi, for putting this together. I think it's a great event. I've learned quite a bit today on a number of topics. Many topics I had not been previously exposed to. So it's been great for that. So thanks for having me. So today I'm going to be discussing what's referred to as modern natural gas development from shale formations, or what's commonly referred to as fracking. I'll try to give you a sense of what this type of energy production actually is and address some of the environmental and public health concerns that arise from it. So fracking itself is just short term for hydraulic fracturing. Hydraulic fracturing is a well stimulation technique. It's one of several involved in extracting natural gas from shale formations. It's really used as an umbrella term, just a quick and easy way to refer to the entirety of shale gas development. But as I hope you come to see throughout this lecture, the issue is really one that goes far beyond just fracking. Unfortunately, using fracking as an umbrella term has led to a lot of miscommunication among the industry, among the public, among the media, and even among the scientific community. So I'm going to cover what I view to be some of the most essential points about shale gas development, and then I guess tomorrow or out in the hall or at any point in time, if you have any questions, I'd be happy to answer them. Really, before I get started, I want to just give you a word about my organization so you can understand where I'm coming from in all this. There's been quite a few issues addressed today that are pretty controversial, pretty politicized, and the same is definitely true of fracking. So I think also going over the work that my organization does will probably provide a useful framework for thinking about the issue as well. So I work for an organization called Physicians, Scientists, and Engineers for Healthy Energy. We are a multidisciplinary scientific nonprofit that looks at novel energy production techniques, of which shale gas development is one of many. There's shale type oil, which is happening in North Dakota right now and soon to be California, and then renewable energy, obviously. So we grew out of conversations among several faculty members, scientists at Cornell University, really about the need for scientific transparency on a lot of issues like shale gas development. I think what all of our founding board members really recognized was the need for a multidisciplinary perspective. So why a multidisciplinary perspective? Well, when you examine the potential environmental impacts, the potential public health outcomes for an issue as complex as shale gas development, you really need a range of perspectives. You need engineers who can tell you about the potential mechanisms for failure, what can initially go wrong in order for contaminants to end up in the environment. You need environmental scientists to be able to go over pathways of exposure and how these certain toxins can end up in the human health arena. And then finally, you obviously need the medical professionals to determine what the health outcomes might be. And this is both at the individual level, so physicians, and then also at the community level, so this is public health professionals, epidemiologists. So with these principles in mind, I think, along with the dearth of objective scientific information on shale gas development, We were really formed in 2010. Since then, we've expanded. We've brought on a number of other scientific experts from universities around the country to really broaden our focus. We've begun transitioning more and more to renewable energy. While we did start with just shale gas, we're looking for solutions now more than just identifying potential environmental issues. So we're a national organization. We started in Ithaca, New York. We have offices now in New York City and Oakland, California. I physically work out of Cornell's Medical College in Manhattan. But we also obviously communicate with a lot of different people around the world. Energy is clearly a global issue. So most recently we had a research workshop in the UK at the London School of Hygiene and Tropical Medicine. This brought together a number of different scientists and government officials, both from the United States and the UK. We've had similar conferences here in the United States, including one in 2012 in Washington, D.C. This was really the first organized conference to address directly the issue of epidemiology and methodological difficulties in study design. So again, our mission is really about scientific transparency for important public policy issues surrounding novel energy production techniques like shale gas. And we do this by generating, translating, and disseminating objective evidence-based information. We deliver this information to a number of stakeholders, including the general public, environmental groups, policymakers. And so again, while we did focus mostly on shale gas, we've been transitioning slowly to renewables. The reason we've looked scrutinized shale gas so much is in part to do with the climate. Climate change is obviously a pretty serious problem, as are environmental and human health concerns. So with that in mind, I really invite you to visit our website. It's www.psehealthyenergy.org. If you didn't have time to write that down, which I'm guessing you didn't, please see me after. I have business cards. Really what we do, we put a lot of science, vetted science on our website, analysis, commentaries, that kind of thing, both on shale gas and other forms of energy. So with that being said, really within the past decade, natural gas has come to the forefront of the world's energy discussion. This has really been due to novel drilling and well stimulation techniques that have enabled the extraction of natural gas from shale formations, which contain vast quantities of this resource and have been found all throughout the world. It's mainly just developed right now in the United States and Canada, but there's a number of countries like China and the UK, Poland, South Africa that are looking to also develop this resource. So we've known for quite some time that natural gas exists in shale, but not until pretty recently have we really had an economically feasible means of extracting it. So new constellations of previously existing technologies have really made this development possible. They're the reason that shale gas now constitutes over 40% of United States natural gas production. And just to give you a sense of what this means, that's up from just 2% in the year 2000. So this has been nothing short of a boom. Shale gas development is just one form of several types of novel energy, unconventional natural gas development. This differs from conventional gas development, where natural gas is extracted easily, relatively easily from porous rock zones where it's trapped. So traditional methods typically just involve drilling a vertical well into pockets where natural gas is accumulated. The differences between conventional drilling and unconventional drilling really have to do mainly with the manner, the cost, and the ease of extraction. For the sake of this lecture, I'm going to deal mostly with the former and start, I guess, by briefly describing some of the principal technologies that are employed. Yeah?
Can I ask a question?
Absolutely.
My name is John Masseria. I'm from climateviewer.com.
Sure.
Are you, I did look at your website. Are you pro fracking?
No.
Okay. Are you working for any of the organizations that promote gas?
No. We try to remain objective. I mean, our goal is just to provide the science.
Because so far, I'm just speaking candidly here.
Yeah.
I'm just confused because I think that everybody should know that fracking is bad. Have you come to that same conclusion?
So we're actually often accused of taking that position. So I'd say, if anything, we're want to transition beyond fossil fuels. So I would say we're more in that camp than the other camp. I don't know what I've said so far that gives you the sense that we're pro-fracking.
It sounds like you're throwing out a lot of terms and not bringing up any fracking materials that are used for fracking.
Okay, well, that's what I'm getting into.
Okay.
I just wanted to kind of paint the
I just
picture.
want to make sure that you're
Sure.
kind of on our side and not the gas company side. You know what I mean? Okay.
Yeah, no, I'm definitely not working for the gas company,
Okay,
I can
just
assure you.
want to make sure. 'Cause
Yeah, sure.
We do deploy a lot of people.
Yeah. So shale itself is a fine-grained sedimentary rock. It's composed of mud. It's mixed with clay minerals and fragments of other minerals such as quartz. Shale formations themselves can vary considerably with regard to characteristics. The Marcellus Shale is about 400 million years old. It stretches throughout much of the Northeast, including Pennsylvania, West Virginia, Ohio, Maryland, and of course New York, which is why we're here today. Fracking will not occur in Long Island, but there are, I think, an LNG export facility that's planned, which would mean that, say, Marcellus gas in Pennsylvania would be transmitted to Long Island and then possibly shipped from here. But it's certainly, it's the climate change issue is one that affects all of us, and I'll get into that shortly. So the depth of shale formations can vary considerably. I'd say typically they're about 5,000 feet underground. They can be as deep as 9,000 feet, and they extend in all directions, which is why new technologies are really required to extract natural gas from shale. So that the full proper name of what most people refer to just as fracking is high-volume horizontal hydraulic fracturing with long laterals from clustered multi-well pads. So directional drilling or horizontal drilling, that's a mouthful, I know. Fracking is the reason we use that term. Directional drilling and long laterals are used, they're introduced to get this natural gas from this relatively thin layer of shale which is buried far beneath our feet, extending in all directions. So because natural gas is trapped in the shale and really distributed throughout the formation, that's only a few hundred feet thick, the industry drills down and then horizontally into the shale, which makes it economically feasible. This requires multi-well pads and clustered drilling, along with high frac fluid volumes, which are required to stimulate the gas from these many existing fractures. So chemicals are added to mixtures of water and sand to pump large volumes of frac fluid at high pressures, very quickly, over very long distances, so typically about a mile down, up to 2 miles across. This is through a small diameter casing. So that frac fluid, that slick water, and this is what I'm getting into chemicals, it's typically 91% water, about 8% sand, which is used as a proppant. That's to keep the cracks of the formation open so the natural gas can flow out. And then about 0.5% to 2% chemicals, which doesn't sound like a lot, but when you consider the volume of the actual fluid, which is, for each well, 3 to 5 million gallons of frac fluid, that's quite a few gallons of chemicals. That's hundreds of thousands of gallons of chemicals that we're putting in. The industry does not have to disclose what these chemicals are. Many are known carcinogens. Some are safe drinking water regulated chemicals. There are voluntary disclosure sites. FracFocus is one of them. There are significant shortcomings with these sites. They're definitely not comprehensive. So there's still quite a bit we don't know about what they're putting into the ground. However, there have been studies that have shown some of it. So again, an average of 2 to 5 million gallons of this fluid is used in the process. About 10 to 70% of that will flow back to the surface before the natural gas is produced. Up with that are other toxic substances which were previously stored safely underground. These include heavy metals, naturally occurring radioactive materials, volatile organic compounds, stuff that's been safely buried in the shale formation for 400 million years is coming back to the surface. So really what's important, I think, to understand about this type of unconventional natural gas development is spatial intensity. Again, extracting natural gas from shale formations requires an industrial build-out that's orders of magnitude larger than that required for traditional natural gas development. So we need to keep this in mind when we consider the consequences. We also need to keep this in mind when we look at what's happened so far in places like Pennsylvania, and also what we can expect in places like Pennsylvania as the build-out continues. So we've heard quite a bit of complaints coming from Pennsylvania already. Just to give you a sense of where they're at with development, they have about 7,000 wells drilled right now, which is considerable. That's a lot. That's since 2008, so that's quite a big build-out. What they're projecting in Pennsylvania alone is 100,000. So that's 7%. Of that 7%, of those 7,000 wells, only about half of those have actually been fracked. I'll repeat that. Only about half of those have actually been fracked. So that's about 3 to 4% of the eventual build-out that we've seen so far, and we're already seeing all these complaints. So we can start looking ahead in terms of what we can expect in terms of wastewater spills that have occurred and will occur, private water well incidents, contamination incidents, truck traffic accidents, health outcomes. What are these numbers going to look like down the road when 10% or 20% or 80 or 90% of Pennsylvania is developed? So as I alluded to in the beginning, fracking or hydraulic fracturing is really not the only issue that concerns us. I think the activities that actually take place on the surface are far more important and deserve more attention. There's about 200,000 wells in total planned throughout the entire Marcellus Shale. So that's Pennsylvania, New York, West Virginia, and Ohio. So along with all these wells, you have all the built infrastructure, all the ancillary infrastructure. So you're not just extracting the natural gas, you have to clean it, you have to process it, you have to compress it for pipelines, you have to transport it. So with all that comes all this infrastructure. There's certainly problems associated with that. Surface spills of fracturing fluid, issues with storage, transport of wastewater, tropospheric ozone caused by heavy truck traffic. Each well, again, uses millions of gallons of frac fluid, so that has to be transported to a well site. That requires, each truck, typically, I'd say 3,000 gallons per truck. That's thousands of truck trips descending on these small rural communities. So that's significant. Diesel particulate matter interacts, VOCs interact with sunlight, CH4 methane interacts with sunlight to form tropospheric ozone. That's a hazardous respiratory irritant. That's something we certainly need to take into account. People tend to focus on just the groundwater. That's certainly a significant issue, but air pollution is just as important, I think. Now, there are clearly benefits that we can't ignore to this industry. Shale gas development provides a potential for economic growth, for jobs, for energy independence. Natural gas itself burns cleaner and emits less CO2 into the atmosphere than other forms of fossil fuels, such as coal. And of course, all our energy comes at a price. There's no form of energy production that's entirely benign. So the question really just becomes, how much environmental degradation are we willing to tolerate in exchange for our energy, and where are we willing to tolerate it? All of our energy has to come from somewhere. So however, these certain benefits do need to be put in context and considered alongside the impacts to the environment, to public health and climate. I think climate change is and really should remain a significant part of the conversation. There's certainly a fair amount of research underway to determine the contribution of shale gas development to greenhouse gas emissions and climate change. So while natural gas does burn cleaner than other types of fossil fuels such as coal, it does emit less carbon into the atmosphere. Natural gas is itself comprised mostly of methane. Methane is a far more potent greenhouse gas, which is leaked and vented into the atmosphere at all stages of production and transmission. So according to recent science, the 2013 Intergovernmental Panel on Climate Change report, methane is about 86 times as potent as CO2 over a 20-year time frame, and about 34 times as potent over a 100-year time frame. So the reason that number is smaller over a longer time period is because the half-life of methane is shorter than CO2, so it's not in the atmosphere as long, but it's certainly more potent. And that matters considerably in the short term, where getting methane under control is very important. We are poised to really reach a critical tipping point in the Earth's climate system that could lead to rapidly accelerating positive feedback in future global warming. Consensus science has suggested that warming the Earth to 1.8 degrees Celsius above the 1890 to 1910 baseline may result in a rapid, significant increase in the release of methane. This is from the Arctic, so up in the Arctic there's all this permafrost, and methane is currently stored under that. So once we melt that permafrost, you're going to have a whole lot of methane just pluming in the atmosphere very significantly and very rapidly. And we're on track to reach that increase, that 1.8 degrees Celsius increase, really within the next 15 to 30 years. So that 20-year time frame really matters. And arguably, I think methane is more important to get under control than CO2 in the short term. CO2 is obviously a significant problem too, and that's going to be one that we're dealing with for quite some time. But we really do need to pay attention to both. And I think in the short term, we need to pay close attention to methane. So in addition to, I think, the primary environmental concerns like climate change, air pollution, water pollution, there's also a number of social and community concerns that really need to be taken into account. This is a heavy industrial activity with thousands of transient workers descending upon these small rural populations. I think there's a number of outcomes that we've seen and can successfully predict from this occurrence. High rates of crime, alcoholism, rape, theft. These are just some of the social concerns that social scientists are looking at. Also keep in mind that in many of these rural communities there's environmental justice issues, so a lot of these communities where it's taking place have socioeconomically disadvantaged populations that are going to be less apt to deal with the consequences of shale gas development. So I think really there's just several main points I want you to take away. I think the first is just the magnitude of this new type of natural gas development is really unprecedented. I think there's a paucity of epidemiological research on the actual health outcomes, and I think we should definitely ask for more of that. And then I think that the process itself presents numerous hazards with considerable potential for harm. I think we've seen some of this harm already, but keep that in mind as we continue to gear up production, which is actually recently slowed just because the price of natural gas is so low. But we'll see what happens in the future. There's definitely a lot of countries looking to exploit this resource. I think there's a number of ethical issues that arise in this discussion. And I think in the end, decisions on whether or not to proceed with shale gas development are really ultimately questions about value than they are questions about science. I don't think any amount of science is really going to convince shale gas proponents or opponents on its merits. I think we've seen this play out with the climate change debate. I mean, 99% of scientists are in consensus, but you still have a debate about climate change among the public. While science provides, I think, an important and necessary foundation from which rational policy decisions can be made, science on its own is not enough. Science cannot determine how much risk we should accept and how we should weigh really competing goods, so economic benefits and environmental degradation. Science, of course, can inform these decisions by providing data from which rational and, I think, ethical determinations can be made. For instance, should we really be developing shale gas if it turns out that from a climate change standpoint it's worse than coal? But again, these are ultimately going to be determined by certain values. I think most of the questions are technical in nature and rely on technical answers, but again, one part of the equation. So I think we as a society have to ask ourselves what types of energy development schemes best contribute to shared visions of the good life. I think more healthy and sustainable visions of the future. And again, one of value, not just science and technological feasibility. So thanks again for having me. I realize this was a little drier than some of the other presentations. That's just my background. That's the part of the debate that I'm engaged in. There's certainly plenty of room for advocacy and activism. I'd be happy to discuss more in depth some of my own feelings on the issue, but in terms of what I do as a profession, this is it.